let's get started with this fucking bullshit. This is it's not a bullshit. It's kind of a bullshit, but is what we call, generalized bullshit. So when there's something that is a big bullshit that everybody needs to comply to, this is basically leetcode, but it helps. It's not entirely a bullshit. So it's just a way to put that as a bullshit. It's not actually a bullshit. Because as soon as you start digging into the bullshit, you start finding some interesting things on that. What I'm saying, it stinks a bit. It's a bit grudgy and all that, but we can find some precious metals sometimes. you know Even some interesting insects and stuff like that. Regardless, this is set matrix zeros, which is a medium problem. I was digging into like this past 2 days. It took me 2 days to break that down basically into these three solutions, and understand like these three solutions properly. So let's start with the first solution. So let's first read the problem. The problem states that when I'll try to be quick, but I'm sure that you can read that on your own. At this point, we are solving a medium exercise. We have other videos here. You can look into other videos, and you know, there's plenty of videos about that on YouTube as well. So basically, the problem states that whenever there's a zero on the initial state, we should like cross that column and row with zeros, basically. And that means, for example, it's only for the initial state. That's simple as that. We receive a matrix which is an array of arrays, and then we need to set that to those columns to zero. We fall short into brute force solutions, because if we start iterating like from into a matrix, which a matrix takes OMN, basically OM plus n, where we need to iterate plus a number of rows and number of columns, basically for m it's mxn or m plus n. I think it's mn, right? Yeah, mxn actually. The on square. That would be the big O for this, basically, because we are, if n is n, so it's be n xn, which is n squared. So in this case, we have n squared here for a brute force solution, where ideally we thinking about this, we would like, okay, let's iterate to each item, and whenever we see a zero, we're gonna make across like a row and column, like all this should be zero, and all this should be and all these rows should be zero, and all these columns should be zero. And that's not different here. We could do the same. Hi, if I'm start iterating through the items in the matrix, and like, this is zero. Yeah, it's zero. Okay, let's make it all this guy zero. But then it's like, if we do this for the first item on on an ongoing loop, for example, if I do that, if I'm iterating here and I get this first loop and I convert this row and column to zero, what's going to happen is that on the next iteration we'll fall short into this, because all these zeros will be already zero, and the next iteration will try to catch zero, and probably will convert all the columns to zero, and so that doesn't work, basically, right? So what's the solution here? Instead of using zeros, basically what we do is we convert the zeros to the ones on the column that's their zero to minus one. For example, on this column here, what we do, that will be, for example, we start a loop here and start marking down the items. For example, we have 1 1 0 0, and then we start iterating here to the first item, and then we got the zero here, so we start looping on the column and the row. So basically what we do, we mark all those ones in this column and in this row as minus one, basically. All these guys here, for example, we found zero on the first occasion that we find zero here, and then we mark all the ones on this row and this column as minus one, basically. So we're gonna iterate this row, and we're gonna iterate this column, basically, and marking all ones as minus one, so we don't need to change anything to zero. So then we keep doing that, and we do that the same on when we find the other zero here. We mark the column and the row, -1. And yeah, after that we would like to loop again basically. So basically what we're going to do here, we would loop again and change all the -1s to 0. That's approach 1. So basically we have like iteration first to one iteration to, you know, to run to the matrix, and then for each item we do an mn again basically. And yeah, that will be like a on cubic, something like that, to this type of, because then we're going to iterate again. So I'm not really sure that that big O is, but it doesn't seem to be very straightforward. But I would say the big O is like we have first OMXN, and then that would be ON squared, and then we do another ON, we do like OM plus N, and then OM plus N, so OM on square ON cubic plus ON, so it'd be O N square and cubic plus O M plus N basically. I think that will be the big O here. Let me see if I'm wrong. Let me check it. It is basically this, so I wasn't completely wrong, but the right way to type this is something like, because MXN, MN, M plus N basically, so that's the way we type it. So in case M is equal N, we have N squared, and then basically would have an N cubic, if I'm not mistaken. Let me see. Yeah, OMN plus MN. Yes. So yeah. So that's it. That would be the first solution here. I won't go through that. I tested it, I developed it, so I just want to cover it with you guys. Basically, how is the solution made here. Then we have the second solution, which solution uses like in-memory pointers basically. We create two objects to kind of track down the columns and rows that we want to zero out, because whenever we have a 0 here, we already know that we need to zero down that row and that column, right? So what we do is basically we're creating a board here, like a strategic mapping from the specific positions like quarters or whatsoever, and we will have like this markdown here. Let's say that we have another 0 here, we'll mark down that row as well. So we can now say that, for example, these and these will be, you know, zeroed out, and, you know, zeroed out. Do you get me? So that's basically what the solution states as a solution, as like the strategy to solve this. That use OMN space because we will have these two objects, and they can at some point, you know, use the a lot of the or whatnot. You know, the some use cases it can get filled with multiple zeros here. So in the worst case, we will have OMN space for that. That's a simple solution. It's a simple solution in my opinion. Thought it uses MN is very straightforward. We just need to loop through the matrix. Then whenever we detect a 0, we mark down I and J positions on each specific object. For example, columns object and rows object. We mark down a specific index for the column and a specific index for the row and a specific index for the column, and then we iterate back again, and whenever we find that index was true, we can zero out that specific row and on that specific you know, object that sits on that specific markdown area. That's very simple, and I think I like that. I like very much this strategy because it's easy to understand and simple to tackle. The second and the optimal strategy uses in place pointers. It is all one space, so we don't have any extra space here. We try to use those markdown objects inside the array. Basically, it's not that we create other objects, we just leverage what we have here inside the array and try to mark it down. Basically, we kind of shrink the space here to what we have, which we call in place, to other in-memory objects to store those pointers. Basically, we will use the first row and the first column as those objects, basically. So instead of having these guys here as we had before, we will have those in place here inside the array. That works. How it works, for example, if we have a use case here, the only problem is that there's some overlapping here with the column and the rows, because we would have like an entire row and entire column for us if we had this. But the problem is when we put those things inside, we have to, you know, create some sort of new spacing here. For example, this should come down, or we can do also the opposite. We can do something like this if we want, you know. But I followed this approach where I decided to take the row here and creating these objects to be a part like of this specific column here, the first column, you know. So we will have the first column and the first row as the markdown area that will define the strategic position of the zeros. So basically, I'm iterating here on the first item, 0, and then until I get to the first 0, and that means that this needs to be zeroed out, this row and this column needs to be zeroed out, basically. And how to achieve that? Basically, we would have like to mark down the first item in the row and the first item in the column as zeros. So in this is the first item in the column, so it's already 0, but we mark down as 0. And how do we say that? Knowing that this is 0, 2, basically, and if my matrix ij is equal 0, and this is O2, so if matrix I, which is 0, 0, then we say that is 0, so mat I 0, so that means the row is 0, and the first item in the row is 0, so the first thing we mark down this guy here. That's the first thing that we did here. Okay, I'll mark down this first item in the row, and then I mark the first item in the column. So what the column is, so basically the column is J, so the column is 2. So I'll mark 2 with 0 as well, because is greater than 0. So the only exception here is the first column. Whenever the column is not the first column, we need to, this means this is not the first column, so we can mark down as 0 here normally. And as for example, when we get to this use case here, for example, we would have to mark the exception where code 0 is equal true, because that will be 0. And it won't fit into this case where j is greater than 0, because that will be 0, and then what we do, we mark down the code 0 is equal true, basically. With that being said, then we basically we'll have the markdown properly. So okay, I'll mark down this first 0 for the column, the first 0 for the row, and I go continue iterating, and then I get another 0 here. So this is already marked, but I also need to mark down the second row and the first column. So basically this means this is 1, 2, so that means that the column that should be marked is already marked, 2, and and the row 0 should be marked. This guy should be marked because, and the first item in column 2 should be marked because it's 1 2. First item column 1, first item column first item row 1, first item column 2, both marked. Okay. Then I keep iterating, and in this case here, when I get to this case, I'll see that it is greater. It is not greater than 0. So what we're going to do, we're going to mark this exception as true, and we can guarantee that this is marked. And we also can mark this the 2 here, so the first item in the column, which is this guy, column 0, and then we mark down this the last row as well, mat I0, so mat 2 0 basically, which is this case. And then we mark that down, and everyone is now satisfied. There's a problem here because if we started iterating, we already marked down in place here. So we fall short into the same problem that we felt before on brute force solution, where we already have 0 marked here. So that means like we'll basically screw with everything, marking zeros where we don't want to. So what we want here is we want to retain to the short space here, skipping row 1 and column 1. So we first then iterate through these guys here, right? Skipping column 1 and row 1 would be an error like this if the matrix was bigger, for example. So we iterate through these guys here, and we mark them down. We zero them based on, and then we zero them based on if the row or the column, the first row or the first column items are marked as 0, then we zero them down. So if we're in this case here, we have a 0 here. So we will iterate through the first, skipping the first row and first column, and we will zero this down because we have zeros there. And we'll do the same here. We will zero this down and zero this down. Okay, and then we can follow the strategy here for example, if we check that call 0, and then we would have another condition that will say if call 0, we could say that, for example, yeah, we would iterate mark all call as 0, and then we can, and then if mat 0 is equal 0, mark all row, all call, and all row as 0. That's it, basically. In short, that's what we have here. Those are the use cases that we have, and there's a similar iteration that I did here back in the day. So but I did with row, but in this case we're using call. Anyways, I think we're good for coding at this point. Well, that's it. Done and dusted. One more to the bucket.